Hello everyone. Now let's look at a new LeetCode problem. This is problem 70. Climbing stairs. Climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Alright, so let me read the problem. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. So n equals x plus 2y. So x, you can think of x is the number of step 1 and y is the number of 2 steps. And you want to find how many possible combinations that can actually in how many distinct ways. Alright, so the order matters here. And we want to find how many ways. Okay, so I think I got the problem. Now let me go through the examples to make sure I understand the problem. Example 1. Actually, let me write down some notes. Total equal n steps. For each step, it could be 1 or 2. And you want to return number of ways. Okay, so example 1, we have n equals 2. Output is, let's see, we can do it by 1 plus 1 or just 2. So that would be 2 solution. There are 2 ways to climb to the top, 1 plus 1 or 2. Example 2, let's see what we got here. N equals 3. How many ways are there? So we could do 1 plus 1 plus 1, or 1 plus 2, or 2 plus 1. Okay, so there are 3 steps, right? We got it correct. And I think okay, let's look at I think I got the problem now. Before I continue, I want to clarify a few things. So clarify, we assume that n is larger than 0. So we are given that n is between 1 to 45. Now good. So let me think of some possible solution here. I think one way on top of my head, if we do it in from the sub problem back to the top, then we see that in the smaller case, so let's just look at some more examples of how we can do this. So let me write down, if n is 1, then how many ways are there? There are only 1. If n is 2, how many ways are there? There is 1 plus 1 or 2. If n is 3, then there is 1 plus 1 plus 1 or 1 plus 2 or 2 plus 1. Okay, now we see that there is a kind of recursive solution. So if n equals 2, if we take one step, there will be, we will have 1 and 2. So let's see, 1 plus f of n equals 1. And then this is 2 plus f of n equals 0. Or if we expand it further, 2 minus 1, 2 minus 2, 1 and 2. Example 3 here. If we see here, this 2 at the top, this is actually 1 plus f of n equals 3 minus 1 equals 2. And then this would be 2 plus f of n equals 3 minus 2 equals 1. So I think this is how we're gonna do that. What we're gonna do is we could do it from the bottom to the top, where fn say okay, so fn equals f or n minus 1 plus f of n minus 2. Okay, so that would be how we're gonna do this, because at each step we either take one step or we take two steps, and from there we can count the total by adding up the number of ways if we take one step, and also the number of ways if we take just two steps. And don't forget the base case, where f0 is just how many ways to do that, just 0. f1, that is one way, and f2, I think f2 is not a base case. Yeah, f2 is not base case. Actually, f2, how many ways to reach that? f0 plus f1 actually f0 doesn't make sense at all. So let me cross that out. So f2, there are two ways. We take 1 or 2 directly. So two ways. And yeah, I think that would be it. So how about we just expand more? So f3, this would give us 3, which is correct. And then f4, this would give us 5. Now let's expand this for f4. So if n is 4, then we have 1, 1, 1, 1, 1, 1, 1. Actually, let me just remove the plus. So it's just a series of 1 and 2. So 1, 1, 1, 1, 1, 1, 2, 1, 2, 1, 2, 1, 1, And then we could do 2, 2, 1, 2, 3, 4, 5. Yes, we got it correct. F5, that is 8. So how do we get 8? Let's expand this. 1, 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 1. Then we could also do 1, 2, 2, and then 2, 1, 2, 2, 2, 1. I think that would be it. Yeah, so and 2, 3, 4, 5, 6, 7, 8. Yeah, we got it, right? So I think I'm pretty confident about the recurrence function there. Does this sound reasonable to you? I would like to start implementing unless you would like me to explore further optimization. Alright, first of all, I think there are two ways we could do it, recursively or iteratively. I think it's much cleaner to do it iteratively, so let's do it that way. First of all, let's do it this way. How are we gonna do it? I think we could say we could use two variables. One is to store the f of n minus 2, and then the other variable is for n minus 1. So how about we call it f1 and f2? So let me just write down some comment here. This would be f equals f1 plus f2. Okay, let's begin. So we have initially f1 equals 1, f2 equals 2. And then we are gonna loop for I in range I think the input is n. Yes, it is n. So we could do f1 comma f2. This would equals f2, and then this would be f1 plus f2. And then in the beginning, if n is 1, return f1. If n is 2, return f2. In the end, we just return, let's say, f1 plus f2. Actually, the loop should begins with what they say. This should be 3, yeah. From range of 3 to n. Because otherwise we have loop it through. So let me test the code. Let me quickly check the code and walk through it to make sure I don't miss anything. First of all, we have f1 and then f2. Now if n is 1 or n is 2, we return f1 and f2 respectively, because that would be the base case and the solution. Otherwise, we need to use the recurrence function to find our solution. And in that case, we would look through from f3 up to fn minus 1, because in the end we just return the f1 plus f2. So what I'm gonna do is we look through from 3 to n minus 1. Then f1 we will assign f2, and then f2 will be assigned to f1 plus f2. So now let me test the code. So if n is 1, that will return 1, correct? And 2 would return true. And 3, now n3 would give us, that will be, it doesn't go into the loop at all because n is 3. So this will give us 1 plus 2, which is 3. If n is 4, it will enter the loop once. So f1 and f2. Okay, here we begin with f1 and f2. So this would give us f1 becomes f2, which is 2, and then f2 becomes f1 plus f2, which is 3. Then in the end this would give us 5. N is 5. Again, we just look through using the previous answer that we got. This would give us, no, this would be 5 and 8, is it? Yeah. Oh, sorry. So n is 5. 2, 3, and then 3 will be moved to f1. And then this would be the 5. Okay. Now this would give us 8. And so on and so on. I think we got this right. Now let me quickly put the code. Actually, let us discuss about the complexity here. The complexity, because it is just one for loop, and then we look through the range of n, then this will give us O(n) complexity. Sorry, this is time, and then O1 space. Okay, now let me quickly code this up to make sure it all as expected. So f1 and f2, how about we call it pref1 and pref2? So pref1, then pref2 equals 1 and 2. If n is 1, return pref1, and if n is 2, return pref2. So let's just use if, and then we look through for the I range of 3 to n. Then we're gonna do pref1, pref2 equals pref2, pref1 plus pref2. In the end, we just return pref1 plus pref2. Let's test this. For I in range, yep, we got it right. Let's try to submit it. Hopefully we got everything correct here. And yes, we got it correct. So complexity looks good. Memory, I think, looks pretty good. I think there is not much optimization that we could do. Yeah, that's what I see too. Okay, the other solution are using some kind of optimization there, but I don't quite like it because it can cause some confusion. I think my solution is very explicit what I'm doing here. So I think that's about it. Let's stop the video here. Thank you everyone.